I'm Anil Kumar, sharing with you a practical application where discrete information is being translated and used for calculating or analyzing situations using normal distribution concepts. The question here is, a company produces candy jars. The number of pieces in each jar is assumed to be normally distributed with a mean of 50 and standard deviation of 4.4. What is the probability that a box selected randomly contains exactly 45 pieces? Part B is, a box with less than 45 pieces is rejected. What percent of the production will be rejected? And that's a very interesting question. It's a practical question. In any industry, we are mass producing things, and therefore the discrete data can be treated as a continuous data, and we can use the normal distribution tables to analyze and predict situations in such cases. So that's the importance. Now in this, what we are given here is we are given a normal distribution with mean of 50. So let me sketch the situation here first, and then we will analyze it one by one. So we'll just draw a normal graph here. Okay, so in this normal graph, mean is given to us as equals to 50. So this value right in the center is 50. Standard deviation of 4.4. So that means the points here, one standard deviation away, are 4.4 away. So we have 54.4, and less 4.4 will be 45.6, right? So these are one standard deviation away, right? So this is for us, this is mean, right? And this is mean plus standard deviation, and this is mean minus standard deviation. Anyway, now it says, what is the probability that the box selected randomly contains exactly 45 pieces? Now in case of continuous distribution, the answer would have been 0, right? In continuous distribution, when we talk about exact values, the area becomes 0 for the interval, correct? Since the interval width is 0. But in this condition, when we are talking about discrete data, then we can say the probability for being 45 like this could be treated as probability. So 45 is a discrete number which is between 44.5, right? So we say our random variable is between 44.5 and 45.5. Does it make sense? So this x could actually take only one value, 45, right? So here you can think about this small slice on the left side of this portion here somewhere, left side. So that is the portion. So we are saying this interval is very small, correct? And that is the area which we are interested in finding. Correct? So that is how we could do. And what we will do here is we'll translate this into z-score. So we can write this as probability for. So to write them in z-scores, we have to take away the mean, divide by standard deviations. We have 44.5 minus mean. And what is the mean for us? 50. Divide by 4.4, the standard deviation. So this is now translated to z-score. Do you see that? And on this side, 45.5 minus 50 divided by 4.4. So we have translated the numbers to z-score. Once we do that, we could use the standardized z-score tables, right? That's the idea. So let's find what this value is. 44.5 minus 50 is minus 11 over 2 divided by 4.4 equals to minus 1.5 in decimals. This could be written as minus 1.25, right? and this score is 45.5. Take away 50, divide by 4.4, gives us in decimals a value which is minus 1.0227. Now whenever we are going to use the z-score, we have to round to 2 decimal places since we have those tables, right? So minus 1.02 is what I'm going to write. This really means what? Let's try to understand that also. So that means we are looking for z-score between these two values, right? So between these two values really means that this value is that one on the right side of this, right? So the idea is that less than. So I'm going to use the table which will have z-scores from the left side. So I'm going to use this table which gives you standard normal distribution table, represent area to the left of z-score, right? So we are using the left side. So what we will do is we can write this as probability that score where z-score is less than minus 1.02, take away probability where z-score is less than minus 1.25. Then we get that interval. Do you see that? That's what we will do. Now from the table. So that means this one is the red line which I've drawn, and minus 1.25 will be this line. Is it okay? So we are subtracting those two to get this area in between. That's the whole idea. So let's read from the standard normal distribution table. The value for, we're looking for minus 1.02, right? So 1.0 and then 2. So minus 1.0 right here, minus 1.0, and 2 is the third column, 0.15386. So it is 0.15386, take away minus 1.25. So minus 1.2 and 5 is there, 0.10565. 0.10565, right? So that's the value. So this is what we get. So let's take away and find the probability. So it is 0.15386 minus 0.1056, which gives you in decimals equals to 0.04826. That is around approximately 4.8%. Do you see that? So 4.8% boxes will have exactly 45 pieces. Right? That is how we could get that answer. So I hope these calculations are clear. What we did was we translated. So this is kind of a translation into Z scores, and then we use the tables to find the value. So we could actually analyze discrete data also using normal distribution. Now part B is box with less than 45 pieces is rejected. So what is that percent of rejection? So box less than 45, so we are doing part B now. So probability for X being less than 45. So that is in z-score, we'll say probability for z being less than 45 minus 50 divided by the deviation, which is 4.4. So let's calculate this. So we have 45 minus 50 divided by 4.4 in decimals is equals to probability for z-score to be less than minus 1.136. Let me write this as 4. Okay, so that is what it is. So from the z-scores we can read this value. Minus 1.1. Okay, so minus 1.1 and then 4. Minus 1.1. Let me just push it up here. Minus 1.1 and then 4 is right there. 0.127. 0.1271. So it is equals to 0.12 0.71. That's the probability, right? So we can say percentage of rejection is pretty high in this case. So percentage rejection is 12.7%, right? So you can always convert this to decimals. So that is how we can actually solve discrete data information applications we're using the normal distribution table. So that's very good application, and most of the industries this standard is being followed. I hope you appreciate it. I'm Anil Kumar. You can always share and subscribe my videos. Thank you and all the best.